Welcome to the American Museum of Science and Energy in Oak Ridge, Tennessee. I'm Alan Lowe, the director of this wonderful institution, which is the nation's oldest and we think best museum of science and energy. Behind me you see some of our amazing staff, and you're going to hear from several of them as we walk around the exhibits here at AMSE today. But I want to start by thanking all of you for your interest in AMSE. We hope you visit us often and consider becoming members of the museum. Our work here, I think, is very important. We shine a light on all that Oak Ridge National Laboratory has done through the years to change our world, while teaching broader lessons about STEAM and STEM and inspiring visitors from all around the globe. So with that, staff, you can go to your stations, and we'll begin with the first section of our museum. Please follow me. All of us here in Oak Ridge trace our origins to the Manhattan Project, an amazing undertaking that changed our world forever and certainly left a legacy here in Oak Ridge and East Tennessee. To tell our visitors about that foundation of our work here, we began our permanent exhibit with the section on the Manhattan Project, and specifically the work that occurred right here in Oak Ridge to create the atomic bomb. The level of effort required to accomplish that task, the number of people, the number of disciplines to build a secret city, truly amazing. We have some great artifacts here to help tell that story. I always point out, particularly to our younger guests, the slide rule and the adding machine. They didn't have the benefit of the modern computers we have nowadays to accomplish this task in really, really short order. We have wonderful personal effects here too. Real people did this work, and the social history of that, how they did that, how they accomplished it in a short time, is a big part of our story and underpins everything else. Of course, at the end of the war, the question is, what is next for Oak Ridge, the not-so-secret city anymore? We tell that story right here in AMSE. To tell you more about that, we have Corky Witt, who's going to first talk about national security and big science, and then we'll go on to the other themes of our museum. Corky?
Thank you, Alan. One of the amazing contributions to the nuclear navy by Oak Ridge is when Captain Rickover visited Oak Ridge in 1946. His team learned about nuclear science, thought it had application to the nuclear navy. 9 years later, they launched the USS Nautilus. Today, Oak Ridge produces the fuel and contributes to the powering of the nuclear navy for the submarines and aircraft carriers. Let's go into the big science area and see our two models of the neutron scattering facilities. One is the high flux isotope reactor, which is a steady state beam of neutrons that penetrate the experiment scientists are trying to study on the atomic level. Let's go over to the spallation neutron source, which is a pulsed state of neutrons that hits a target of mercury. The spalling is when the neutrons are knocked out, going down the chambers into the experiments, again allowing scientists to image structures on the atomic level. Oak Ridge produces isotopes for medicine, agriculture, and industry. One in particular is producing the plutonium-238. NASA has a contract with the Oak Ridge National Lab to produce 238 for their RTGs, the radioisotope thermoelectric generators, which provide the energy for deep space missions to Saturn and the Mars. Curiosity rover is being powered by this rare isotope, and it continues to facilitate missions in the future. Next is the supercomputing division. The Summit computer is the world's fastest computer at this time. The supercomputing facility at the Oak Ridge National Lab started in 1990 with the Paragon computer. You'll be amazed to know that the cell phone in your pocket is as powerful as the Paragon was in 1990. The Frontier supercomputer will be coming online in 2021. It'll be 50 times faster than the Summit computer. I'd like to introduce you to my colleague, Kathleen Lyon, who'll be telling you about energy leadership today. Kathleen?
Hi, since the Manhattan Project, nuclear technologies have advanced well beyond the original military applications for which they were developed. Now we split atoms of uranium in a process called fission in nuclear fission reactors. But also researchers have advanced renewable clean energy technologies. And here at the museum we have an interactive exhibit where visitors can actually build their own electric power grid. They can use a variety of power generating resources. In the environmental restoration section of the museum, we find that big science solutions have been brought to bear on big science challenges. The Department of Energy is committed to environmental restoration through a series of step-by-step environmental cleanup processes. We have inspection, removal, demolition, disposal, testing, and treatment. So we take responsibility for the past, but at the same time, we look to the future, and fusion may be in our future. Oak Ridge National Laboratory researchers are working with other scientists from 6 other countries in Nice, France, where they're building the International Thermonuclear Experimental Reactor, called ITER for short. There, they will fuse isotopes of hydrogen together to release lots of usable energy in a process called fusion. The Department of Energy is not just about energy. We know from the equation E equals mc squared that energy and matter are inextricably linked. So at the manufacturing demonstrations facility, we find that materials are being manipulated through 3D printing processes at the macro scale, but we also find at the Center for Nanophase Material Sciences that materials are being printed at the nanoscale. Also, new materials are being developed, like graphene. It has super properties like super transparency, it's lightweight, flexible, has super strength. And these are the properties that will define the limits of science in the future. So when you visit the American Museum of Science and Energy, you not only learn about the past, but you also get to look into the future. And now I'd like to introduce you to our curator, Quinn Argall.
Hi. It's an odd time to be responsible for hands-on exhibits in a hands-off era. Our museum has a long tradition of science and culture-based temporary exhibits that we host in our exploration zone. Eat Well, Play Well is a perfect example of one of these exhibits. It explores the science of good nutrition, encourages exercise, and shows how our body produces energy from food. Children can practice their balancing, or see how many calories are in a baseball or a pack of playing cards, and see how long it takes to work off those calories. As a science and energy museum, we want to promote innovation in ourselves and others. So we're going to innovate this space by inviting regional tech companies to showcase their ideas, materials, and hardware. We want to promote the sciences with real science while that science is being created. And as an earthbound museum, it can be difficult and cost prohibitive to take our visitors to space and other dimensions. And it can be difficult to explain to our donors the science. So we want to use virtual reality and existing programs at ORNL to take our visitors inside ORNL's laboratories, SNS, and HIFER. In the meantime, we're going to use these stations to explore 3D modeling, space, and encourage hands-on science. In our back 2 galleries, we feature the works of Ed Westcott, the official photographer of the Manhattan Project, and in an ongoing collaboration, the works and explorations of the Camera Club of Oak Ridge. Now I'm going to hand you off to one of our wonderful educators, Linnell Wright, who will tell you all about our classrooms.
Welcome to the classroom. This is the hub of activity for school groups that visit throughout the year. Students are allowed to come into the classroom and get their hands on science. They can build something as simple as a series, a parallel circuit, and test conductors and insulators. All of our classroom programs are designed to reinforce what teachers are teaching in the classroom with Common Core standards. We also host a variety of scout troops throughout the year. They travel from as far as Wisconsin to Colorado, Texas, North Carolina, all to earn an Atomic Energy Merit Badge. This particular program allows scouts to utilize equipment they don't normally have access to, like a Geiger counter and hidden sources. They can conduct time, distance, and shielding experiments. They also learn about the atomic pioneers and basic nuclear energy and radiation. We're very fortunate to welcome back one of our old programs, Mr. Stuffy. Mr. Stuffy is now on loan from Tennessee Donor Society. He will help us engage visitors learning more about basic anatomy, the heart, the lungs, the kidneys, and the respiratory system, digestive system, how all these work together to get us up and moving each and every day. We have also been working on developing new stations for our visitors that they can come into the classroom when it's not in use and do some STEAM activities. They can do something like building a catapult, explore with microscopes, or computer coding, accept Lego challenges, or even build a circuit arcade with snap circuits. We also host Family Science Saturday. This particular program has a different monthly theme. For this month, it's going to be solar energy. So they can sign up and register for that class and learn about basic solar energy in the commercial and residential sector and build a solar racer that they can take home with them. We had planned for camp to be in-house this year, and we changed our theme to Mission to Mars to celebrate the Perseverance rover that recently lifted off. However, we had to change gears and go to a virtual format. We utilized an application that is called Flipgrid. Flipgrid is a video-based application, and it allowed our campers to go online and actually introduce themselves and create videos. Talk a little bit more about their interest in science, and the educators also had a chance to create videos as well. After they had introduced themselves, campers could go to a topic page and explore the topic for that week. 3 topics were posted each week for 6 weeks. They created videos.
Hi, this is my space station example thing. And this is where the living station where you eat.
They included videos that the educators created, like building rovers or designing parachutes to actually land that rover on Mars. And they learned about the red planet in general, meteorites, and the surface of Mars. Now that you know a little bit more about what we do in the classroom, I'm going to pass the torch back over to our director, Mr. Alan Lowe.
Thank you, Linnell, and thanks to all of our terrific AMSE staff. I'm really proud of what they do here each and every day to advance our mission. Our work here, I think, is vital. It's important to teach about all the amazing accomplishments of Oak Ridge, but also more broadly to teach lessons of STEM and STEAM for this and future generations. We hope you will visit us often. We hope you'll become members of the museum, and thank you so much for your support.